Hello friends, welcome back to another video on this channel. In today's video, I will show you how you can make this RC turret vehicle thing. So I don't know exactly what you want to call it, but it is quite literally a turret on wheels. As you can see, we have the turret here, which is quite a simple little machine. So over here we have an arm. As you can see, this is where you load the ammo in. So for now, I'm just using this little like aluminum foil round shape thing. I just made that up, just squish a bunch of a little bit of aluminum foil like this, make it round. That's what it is. So over here we have a ramp that is using natural gravity to come down from here. This is just acting as a little gate to open and close this. This is the servo controlling this. I'll show you that in a moment. It is yes, and it moves obviously. Anyways, down here, when it comes down here, we have these two flywheels. So these are just two DC motors which have two wheels attached to them. These are acting as flywheels. So they spin at super high RPMs at this direction. So this one spins like this and this one spins like this. As a result, when the thing comes, it goes flying off this way, and this is just for guiding it straight ahead. Now, as I said, to control the arm, we have this servo here, but additionally, okay, if I stop moving it, as you can see, we have more controls. So first of all, we have the control for the tilt. So as you can see, we can tilt the gun as we desire, and that is, I accidentally turned it on. Anyways, so as you can see, we can tilt the gun as we desire using this slider here. We can move it all the way down, we can move it all the way back. Although I found keeping it around 2 or 3 is the ideal position. I'll link this app down below as well as the code like normal. Anyways, aside from that, of course, I should probably show you the firing first. So in order to fire, we first turn on the flywheel system. Actually, it's a bit too low for my liking. I'm gonna make it go a bit higher. Now to show you how this works, I'm gonna first turn on this, which turns on the turret. As you can see here, the two flywheels are spinning at super high RPM, and you can actually feel the air coming off of it there. I have to speak super loud because this is extremely loud when it's on. Next, I'm gonna click this button which releases that. And as you saw in the slow-mo, I'm gonna put the slow-mo up now. It actually shot off this little bullet, so it came straight flung off like that. I'm gonna show you it another time if it works. It's actually quite finicky because so it's just a bunch of tape and hot glue and stuff holding these two wheels to the thing, and since it's spinning at super high RPMs, 5,000-6,000 RPM, I'm not sure exactly, I'm taking that number off the top of my head, but anyways, that's super high RPM, so it does fly off. So it's super unreliable, and the thickness keeps on changing. As you can clearly see, it's not really that steady either. So yeah, now it's gonna go to full speed now, and I'm gonna try again, and I'm gonna focus the camera a bit more that way so you can see it more clearly. So let's go ahead and hit that button, and as you saw, it just flings it right off like a champ. So now this should be ideally loaded up with many bullets, not just one like now, but it's really a complicated process to make this just the right size, because they have to be not too small but not too big, you know, and I'm doing it by hand, so it's quite complicated, and I could only get like one of them to work. I have many more, but they don't really work. Sometimes they work, sometimes they don't. Some of them are too big, and so they just don't work. They fling off the other way. Some of them are too small, so they just stay here, and eventually due to the vibrations they fall down and stuff. That's just a different matter. Anyways, moving on, I'm going to show you the movement part of it. So we have 4 buttons here, like normal, forward, we have backward, we have turning, and we can turn that way. So yeah, it's again, as you can see, I probably put a bit too much power into it. I really should reduce that, but you know what I say, hey, there's nothing as too much power, eh? So anyways, yeah, too fast, but you get the point. The app works, it moves, it does what it needs to do. That is just look cool, because this is not really anything other than a simple proof of concept, and at a proof of concept for looking really cool, it does just that. Anyways, now for the more detailed part of it, let me show you how this works exactly. Okay, starting off, so I'm gonna move the camera down a bit now, like so. Starting off, we have the turret section. I explained this already, but I'm just gonna go over one more time how this works. The ammo goes in here. This is just a little storage compartment. As you can see, this is all made out of Lego, the turret part. It has this flywheel that is connected to this to hinges, and this side we have the servo, which is hot glued to this side. So when the servo horn moves, like if I show you, as you can see, when I click this button, the servo horn moves and it releases this bullet, or what I'm calling, actually is more appropriately named a projectile. Releases this, it falls down using the natural slope, because this is a slope, so it uses gravity to fall down and into these two motors. These are just two flywheels, so these spin at super high rpm. When they are connected and the button is pressed, they then fling the thing off, and this is there for stability. So this is, I'm not exactly going to put how you can exactly recreate this. This is very much experimental, but anyways, you get the point. So that's the main turret. This is obviously the main attraction. So down here we have another hinge, and this hinge is actually connecting it to this black piece. It's connected by this Lego thing. I don't know what these rods are called. So this black piece is actually hot glued to this platform here. That is acting as the main platform. This is acting the hinge, and then we have this push rod here connected to this Lego piece, to both of these, which is connected to this servo horn. Now for reference, this is a SG90 and this is a MG90S. You could use a SG90 here based on your applications, but you might also need more based on your applications, because obviously this could be quite heavy if you are going like for a very large turret type thing. So even an MG90 might not work, and if you are going smaller, maybe a little bit lower profile, maybe with one motor that's running both flywheels using a bunch of gears and stuff, you might get away with using even an SG90. For reference, this guy has about 2.9 kg centimeters of torque or something like that, and this one is around 1.5. I don't exactly remember. This is almost double of this guy. This also has metal gears, and this has plastic ones so inside. Anyways, moving apart from the turret, next section is actually the bottom. So if we move a bit lower here, we have the tank chassis. So this is actually just a repurposed chassis. Fun fact, the only two things that are repurposed are this tank chassis and the drivetrain. So if we look down in here, this is actually a drive box. So this is running two motors, one right there and one here. You can see there's one motor right there. I don't think you can see it very clearly. Anyways, it's connected to this one, and there's one right there connected to this tire. This is just a little bit geared up, so the high rpm is converted to torque, because this is really heavy. I tell you, I don't have a very accurate scale, so I'm gonna say about 1.5 to 2 kilograms this guy weighs, which for reference is about 3 times the original weight of this. This was around 500 grams. So this is actually a repurposed RC tank chassis. The only the motors, the drive box, actually the motors have been switched out, but the model is still the same, so they're just the same motors. The previous one burnt out, so I switched them out for new ones. Anyways, the drive box, the gearing, the chassis, the treads, and the motors, these are the well, technically the motors, they are the only thing that are being used off the shelf, which was intended for this application. Everything else is custom. Everything from the software to the turret to all these applications, everything is custom. Now the application I'm using on the phone is like not something I did. It's already available on the Play Store. I'm gonna leave a link down to that down below. Anyways, so for power, as I said, okay, first of all, for the motors, we are just using a L298N motor controller here. The good old reliable motor controller, 30 amps max, 12 volts, 30 volt, 32, I think this guy is. It's the upgraded version. I don't remember exactly, but somewhere around the neighborhood of 30 to 32 volts. 10 amps, I believe it is 10 amps max. This guy with the heatsink and everything. This guy is a really old, reliable, but good motor controller. Connecting it up here to the brains of the operation. This is all it takes for the brains of such a incredible machine. I say this is incredible. Of course, this is many times less complicated than some of the other projects. You should check them out down below, by the way, which are way more based on software. Of course, that's true. But this is like a magnificent hardware piece of hardware. Like it is. I put many hours into this so far, aside from one project which is not out yet. I don't know when that will be, but it hopefully soon will be. Aside from that, this is one of the longest projects I have ever done. This is very hard to build because obviously I don't use 3D printers or any more like the fancy tools than hot glue gun and a soldering iron. That's all I have, and then Lego and like literally these hardwood pieces I have to cut them out by hand and stuff like that. So it's very basic tools, so it's very not that easy to set up. So most of this is actually salvage. As you can see, this is a different hardwood, and all of these are different pieces of hardwoods because they're literally all salvaged off of one thing or the other. For example, this is actually a piece of diary. Anyways, I'm taking way too much time here to explain this, so quickly, the Arduino Nano connected to this guy. So this Arduino Nano is the brains of the operation. Now it's also connected to the both the servos which is controlling that, and the 8C05 is the Bluetooth module, as you can see here. For voltage step down, we are just using the regular built-in voltage step down for the L2910. So the 12 volt goes in. As you can see here, this is the main 12 volt line coming in from the battery. This guy is plugging into this rail, which has the 12 volt ground and power going into the L2910, as well as the ground and power going into these relay. This relay is controlling these two motors, by the way. So that, and this relay is obviously connected to here for power. Again, schematics down in the description. That, and there's one ground pin going here to here because the 5 volts is coming from the L2910 5 volt output into the 5 volt input red line here on this rail. The ground is coming in, since ground has to be the same, it doesn't really matter, voltage doesn't matter on ground. It's coming in there. Over on there we are powering the Arduino Nano, the 8C05, and the relays, like the relay where you have to put the 5 volt input for having the relay switch. So that's the brains of the operations. Now we're gonna go ahead and switch over onto the computer to show you the code. Alright, so I have now switched over to the computer. As you can see, this is the simple code running on the software, the microcontroller. It is a bit larger this time. This is better explained when you see the app itself. So a bit detail on how the app works. Basically, it uses simple serial. In fact, all it does is when you press a button on the app, it will send a serial letter, like a letter on the serial. So if we go ahead and click serial monitor, of course no board is connected right now, but if you see, there is a send message normally. So that is exactly what it is doing. It's just sending. Here it's sending, for example, you can see we have L, R, B. These are all just commands. So first of all, let's go ahead and go from the top, including the servo library, naming the servos. Here are all the integers, so the PWMs and the pins. These are for the L2910. We have the variable characters here. These two are actually for something I was trying out later, but this is exactly what we need now. Void setup, simple, setting all to output, starting the serial, making them go. We are making the servos attached to the respected pins, and we are making them in the default position. So this is tilted right about around 10 degrees 10 degrees upwards, and this is just closed position. Then we are starting if serial available. We are saying T as serial read. So this is the variable which we defined earlier here, character. We are gonna go ahead and name it. So if the app sends over L, then we are going to turn left. If it turns right, it says R, we're going to turn right. B, so for back. F for forward. W, small w is here, it's saying LED because I just reused the code for the default app, but this is for going ahead and turning on the relay, which turns on the motors. Turning off is going to be big W, capital W. S is for stopping all the motors. X is for closing the arm. V is for opening the arm. So X is for closing the arm. This is for another app, not the one I'm currently using. For this one, it is V. V, when we click V, it opens the arm, waits for 500 milliseconds, and then closes the arm. And then we have all these other ones for the servo tilt. So from 0 to 9, and then 10 is actually Q, because 1 0 won't come, it only comes single digits. So that is just the different positions. It puts another 100 milliseconds of delay because, you know, too fast, too bad. This is one place where too much speed will completely error out this microcontroller, because it's a super low power microcontroller. We are just using the Arduino Nano, as I said before, which means that it will error out if we try and go much faster than this. And anyways, it's really a simple little robotic car, so you don't need super, like, it's not something you need like very fast reflexes in. It's not a video game, so anyways, that's the code that's running on it. Super simple, no extra additions. Just gonna go ahead and put the code down in the description, download it, upload it onto your software, Arduino Nano. Most likely you're gonna use, you can use the Uno, the Mega, whatever you want to use. Be sure to change these parameters based on your particular microcontroller, where you plug them in. Same with the servos and everything. And make sure you, one thing you should want to make sure, if you are using a lithium polymer like I am, do not by any chance connect the directly to the microcontroller. It will eventually fry it. Trust me, I have lost many microcontrollers like that. If you connect them directly, they say, the microcontrollers say that they are capable of 12 volts input. However, it just does not work. The 12 volts gets super hot and eventually it completely fries the VIN. So then you cannot use any kind of input. And in one case, it completely breaks the microcontroller, and it's literally now, when the code is running, it freezes in between. You have to reset it to make it work again. It's just a mess. Yeah, it damages the microcontrollers permanently, so do not do that. Remember to use the regulators, use 5 volts or whatever. You can use something like this, L2910, or you can use a separate voltage step down module. Anyways, so you get the point. That's it. That's enough for this video. I hope you guys enjoyed. If you did, please be sure to leave a like and subscribe to the channel, and leave a comment on any future ideas, as well as if you have any troubles with this project. Yeah, I'll see you guys next time. Peace.